Kia ora Year 12 and Year 11. Here's video 4 of the June 2021 exam paper for Pure 1. So this is revision of AS content, but it sometimes comes in handy for A-level. Also, if you're in the AS class, you might want to watch this nearer the end of the year for some exam revision. Okay, so the two questions in here. The first one is about composite functions and inverse functions, which is a place where students often muck up until they've got lots and lots of examples done. So I'm going to do some pretty basic revision on what the inverse of a function is and how we can work with the domain and range for inverse functions. Then the second one is one where we've got, first of all, a geometric sequence and then an arithmetic progression or sequence. So there's quite a bit of algebra in these two, but nothing too hard, especially because you are given the formulae for those, although you really should know them by the end of the year. Okay, so let's look at this first one. We've got two functions. We've got f, which takes input x, squares it and subtracts 1, and that's defined for all negative numbers. And then the g function takes in values that are below -1/2 and spits out 1 over 2x plus 1. So the first thing we have to do is to solve this equation here. So f g of x, which equals 3. So that means, first of all, do g to x and then do f to x, and then solve that equation. Next thing we have to do is to take that composite function, fg, and find the inverse of it. And for this part here, we're going to have to be quite careful thinking about what's the domain of fg and what's the range of fg inverse. So first we'll do this first bit, the composite function bit. So we've got f of g of x is equal to 3, but we know that g of x is where we took x and we did 1 over 2x plus 1. So what was the f function? Well, the f function was squaring and then subtracting 1. So we've got this 1 over 2x plus 1 all squared minus 1 equals 3. Now remember, for this, the only values of x that can go in here are ones that are less than -1/2. So we must have x less than -1/2. And then when we put them into the f function, the values must be negative. So that doesn't really add anything. We don't need to worry about that. But the whole way through, we have to think about that in our solution, the x value has to be a negative number below -1/2. So just keep that in your mind. Right, so what am I going to do next? Well, I'm going to have this 1 over 2x plus 1 squared is equal to 4. Multiplying things through, what do we get? Well, we get 1/4 is equal to 2x plus 1 all squared. Now I could expand that and then solve the quadratic. Or, in this case, I could say, well, on this side we've got plus or minus 1/2 is equal to 2x plus 1. Now, it has to have the plus or minus because when this is squared, it will be a positive number, but that could have come from this being either a positive or a negative number. Okay, so if you want to do this the long way and expand it out, go for it. What do I get here? Well, I have 2x plus 1 is that, so we have -1 plus or minus 1/2 is, whoops, turn off ink to shape, is equal to 2x. So on this side, we've got two possible values. -1 minus 1/2 is -3 over 2 is equal to 2x, or -1/2 is equal to 2x. That gives me -3/4 is equal to x, or -1/4 is equal to x. And this is where we have to come back and have a look at my domain. So x has to be less than -1/2, which means that this, I don't know what's come up here. Let's just get rid of that window. There we are. So this is not valid. So not valid since x has to be less than -1/2. And so x is equal to -3/4 is the only solution. Okay, so guys, I might not get through both questions in this video. I think the way this is going, that's the first bit done, right? Okay, next bit, find an expression for f of g of fg of -1 of x. Now, that's a stupid way to say it. What I should have said is the inverse of fg. So before I do that, we're going to have a review of the basic idea of an inverse of a function. And we're going to start with one that has no issues at all. If we have y is equal to 2x plus 3, that's this orange line here. So graphically what we mean when we're taking the inverse is instead of going from x to y, we're going to have things be the other way around. In other words, the inverse you can think of as the reflection in the y equals x axis. So practically, to find the inverse of a function, so here we've got f of x is equal to 2x plus 3, we switch around the input and the output, and then we solve it to make y the subject as usual. So here we're going to go x is equal to 2y plus 3, then rearranging gives me x minus 3 is equal to 2y, so y is equal to a half x minus 3 over 2, and that's that green line there, right? And that should be a pretty familiar concept. So if you're watching this video and you're not good with that, have a chat to me and I'll find you some revision work if you're in A level from the AS textbook. So we've switched over the x and y, and you can see that that's this green line here. And you can see that it's a reflection in y equals x. So there's my point of invariance, and this here is my x-intercept. So before we had 3 was my y-intercept, and now we've got 3 is my x-intercept. And in this case, all we had to do to find that inverse was to think about switching the x and the y. There were no limits on the values of x, and there were no limits on the values of y. But often we have to think about the domain and the range, and we have to think about switching those over. And in this exam question, wherever it's gone, that's going to be a thing, right? So we've got to find an expression for the inverse function here. Okay, so we've got for f of g inverse of x. Well, we started out with f of g of x was the thing that we had in the last question. So that was 1 over 2x plus 1 squared, take away 1, right? So that came from, first of all, g of x was this one here. So it was 1 over 2x plus 1. And then we put that into here, square it and subtract 1. Right, so to find the inverse, what we're going to do here, if we think of that as y, is we're going to switch it. And we're going to have x is equal to 1 over 2y plus 1 squared minus 1. We're going to rearrange it, and we're going to get an expression for y. Then we're going to come back, and we're going to think about the domain and the range. Okay, the domain and the range for the composite function, and then the inverse composite function. So that's the very last bit. First, we get x plus 1 is equal to 1 over 2y plus 1 squared. That gives me 2y plus 1 squared is equal to 1 over x plus 1. Now, making y the subject, we just keep on step by step chugging along. So 2y plus 1 is equal to plus or minus 1 over root x plus 1. Now, at the end, it's going to turn out that only one of those plus or minus branches will work. Right? But first of all, we just work it through like this. So finally, we get that y is equal to negative a half plus or minus a half over, so the root of 1 is just 1, right? So it's 1 over root x plus 1. So we've got two options for fg inverse is either equal to negative a half plus 1 over 2 root x plus 1, or negative a half minus 1 over 2 root x plus 1. So which is valid? So which one? So when I do this, I work with this little table here where I've got the domain and the range for each thing. Okay, so actually in this case what I've done is I've done it this way around. So what's the domain for fg of x? Well, it's x must be less than negative a half. So that then becomes the range for my inverse function. So we end up with the range having to be that the output has to be less than negative a half. So for the basic function, the input is less than negative a half. And the same thing here is that the output of this function has to be values greater than negative 1. And so that then becomes the input in here. Right now, Where did this come from? Well, the y being greater than -1, if we go all the way back to here, you can see that this number here is always going to be positive. And so the lowest it's going to get to is -1, right? So that's why that comes out. And this range here then becomes the domain for my inverse function. So that's going to help me figure out which of these ones I reject. With this one here, we have to have the range of the inverse function has to be lower than -1/2. So let's look at what happens here. Here we've got -1/2 plus some positive number. So that's not going to work because it's going to give me y values that are bigger than -1/2. Right, so just think slowly, think about your number line. Here's 0 and here's -1/2. This one will give me values that are here. So this is the one I want. So we have to have this one here as my inverse function, right? So that there's only one answer and this is the answer. Okay, so that was very long and slow, but hopefully that helped because I know some of you are going to come into A-level having gaps in that skill. Right, let's just see how long this next question is and whether I can get through it. So I think I can get through 9A, but I'm going to leave it. I'm going to do all of question 9 in a separate video, so sorry about that. If you came to watch question 9, you're just going to have to wait for the next video. I think there's no one sitting out there waiting for question 9, so that's fine.